Hello, my name is Leslie Berger, and I would like to welcome you to this episode of Renew. Renew is a show about the College of Forest Resources at Mississippi State. At the College of Forest Resources, we work to promote and enable the conservation, management, and wise use of our natural resources. Joining me today from the Department of Sustainable Bioproducts are some of those people engaged in that work of promoting the conservation of our natural resources. Dr. Jason Zong and his graduate student, Ashani. Welcome.
Thank you. Thank you for having me here today.
I'm really excited to learn more about your work because we are actually in different departments and we don't get to interact. And so I enjoy these opportunities to visit with some of the other faculty and students and other units within the College of Forest Resources to learn a little bit more about their work. So tell me a little bit about your path here to Mississippi State.
Oh, my past year? Well, I am been here for a long time. I actually completed my PhD degree here and then started for 3 years as postdoc, and then I've been promoted as a research assistant professor since 2020. So yeah, I know a lot about Mississippi State and its college. So before I come to US and I study, I got my bachelor and master degree in wood science.
Okay.
From China. So what I did there was use wood as a natural resource, just the material itself, to make furniture, wood composites, buildings, stuff. But after I joined Mississippi State, I participated in some very interesting projects. Mm-hmm. So start from then, I started to look at wood as not only just a bark material, but also a bioresources. And I started to think about how to utilize this as a novel functional material for different processes. And I have been working with making carbon nanomaterials use wood because wood contains carbon. And I have also working on extracting nanofibers, yes. Cellulose nanofibers and making from plastic films and something like that.
Yes, so I actually was going to ask you about that because I was doing a little bit of research and I was, sneaking up on you on the internet. And I found that, in your list of publications, you actually use the word nanomaterials a lot in your publication titles. So not everybody knows what nanomaterials are, and even more so don't know perhaps the connection to trees and to wood. We understand, most people understand things like paper bags, like you brought with you, or this piece of paper, furniture, housing, that comes from wood. But what about nanomaterials?
Okay, okay.
In a non-scientific way.
Okay, I see, yeah. So basically, nanomaterial refers the material they are staying in a very small scale. Nanoscale is actually 10 minus 9 meters.
Nothing
scale.
You're going to see with your eyes.
Yeah, right. So, there's nothing special in terms of chemistry and structure, but the thing really different is if everything goes to very small scale, then their surface area become large. They are more tend to have higher reactivity and may demonstrating some amazing properties like mechanical and reaction. So that's why. But for every material, if you break down to small scale, you will start to see some amazing properties. So that's what I'm working on, breaking wood to small scale.
Okay. Well, I assume that involves this lovely woman next to you, Ashani. So we were talking before the show started that you're actually from Sri Lanka.
Yes.
I assume you're doing something in this realm that he works in, and that is why you're here. So tell me about your path to Mississippi State and what is it that you are here for?
Okay. I graduated in chemistry stream, and then I joined here in 2021 spring. So after coming here, my research is mainly based on this hydrophilic paper materials. So as you know, this paper is hydrophilic. That means it absorbs water quickly. So my project is to reduce the activity to the water. So I used a simple method using metal ions to induce the hydrophobicity to the hydrophilic papers. like this method is really simple to compare the other methods that used in industry. So, yeah.
So we want that paper to be hydrophilic, right? Or normally is. We want it to be
Yeah.
hydrophobic. You know, it's
Yeah.
afraid of water,
Yeah.
so that it doesn't absorb the moisture.
Yeah.
And so what you have is a process that allows you to sort of treat that paper
Yes.
through a series of steps that creates a barrier to water.
Yes.
Okay, so you've brought some demonstration items here that tell us a little bit about the research that you're doing. You have an experiment going on. You told me beforehand it's been going on for 3 weeks, right? So tell me a little about the experiment and how that ties to these paper bags that you've got here in front of you.
Okay, this is like craft packaging paper that we use in the market. So I just convert this into hydrophobic one. You can see it from a small demonstration. Okay, this is the
We have a video.
yeah. This is the paper bag.
Yes.
But to make sure it's to show your. So we did a small video, like small boat.
Okay.
Two boats, like one is modified and other one is unmodified. You can see within a few seconds, like the unmodified boat will sink. So the modified boat, like it's like
It's
in a
still
good
floating. Right. So what you're saying by modified, it's been treated through this
Yes.
special process that you were talking
Yeah,
about, and that keeps the water from being absorbed into
Yes.
the paper.
Yes.
So show us how it works here with your. Can we see it with
Yeah.
with your little spritz bottle?
Yeah, it's easy.
Okay, this is unmodified one?
Yes.
Okay, let's do the unmodified first. This one?
Okay.
Okay.
Okay, it gets
Okay.
wet.
Stop.
Okay.
It's get wet, and you see what has been absorbed.
Right.
And this is now
modified.
modified one. You see, water is flow down.
Ah.
And it's
Okay.
clear.
Yes. So I want my packages that come through the Postal Service to be treated with this
Yes.
rather than this.
Yes.
So when the postal carrier leaves it outside, this keeps it from getting
Yeah.
wet inside, and that one
Right.
does not. That
Yeah.
protects
Because
it.
I think this application is really useful today because of the pandemic, like we
Sure.
have used in online shopping. So
Right, so you can actually be able to use this right now once we get the technology out. So
Yes.
is this a small scale stuff that you're doing? And so the next step will be to
Yes.
scale it up to a larger.
yeah, we are like invite the industry people to collaborate with us to
Right, to be able to incorporate this
yeah.
technology
Yes.
into what they're doing.
yes.
Okay, so how did you come across this idea of being able to use nanoparticles to create waterproof? Or some of your other work was you were actually creating some construction materials, maybe some insulation, if I'm trying to remember the titles.
yeah, I did that
So
as
there's
well.
other things that we can use, and not just to waterproof, but this idea of using nanotechnology tied to wood, to plant materials,
right.
to be able to create things. That's probably not something that people are thinking about. So what other things have you been involved with in your research besides making paper waterproof?
Okay, so my research now is trying to develop a novel method to convert the biomass, especially wood, which is a traditional resource, to a functional materials by just a novel method, and to induce them some different properties like this. So the reason I'm looking at nano is because I have get my master and bachelor degree in wood science, and I have around 6-7 years research experience in making wood products in the micro scale. But as I mentioned earlier, like if everything goes in nano scale, then we have some amazing properties. So since then, I start to think, okay, so how about let's look at the specific those material in the very small scale and see what we can do. And this where I induce those nanotechnology in this wood science area. Not necessarily I have to make it very small, but when I look at the material, I look at the method, a different method, I will always think about, well, in the really small scale, what happened?
Right.
So so instead of using this for making hydrophobic paper, this is mainly modified cellulose. wood have other component, hemicellulose and lignin. Lignin is as a binding material for wood to make wood a rigid and strong material. So, and again, lignin is a waste material during the paper making.
Right, so we can take that lignin that's a waste product, maybe we'll use that into something else rather than throwing it away.
Right. One of my research I involved is just, okay, let's convert this natural adhesive, break down from tree, and make it adhesive again.
Right.
To replace the, petroleum-based.
Right. So we don't instead of using petroleum as our adhesive, we can use this waste product as our adhesive.
Right.
So you can see that idea of sustainability coming through in that kind of work. So we're almost done here, but I want to ask you a question because you are a young woman working in a field that perhaps many high school girls or girls in general don't necessarily even recognize as being an option. Okay. So what inspired you to be a scientist?
Okay, it's a really interesting question. So when I was a child, I'm really curious about the nature. So we can learn so much of things, like if we focus on the nature, even the trees, leaves, if we focus on that, why is there? It's like that. If we question, we can learn a lot of things from that. So that's the main thing. So inspired me to come here to work with sustainable products that comes from the nature. So I choose this field because it's interesting, and we have to deal with the nature in order to, as a human, to live longer or to make environment happy. So we have to work with it.
Right. Instead of against nature, we can work with it and be able to use nature wisely, the things of nature wisely, which includes, instead of throwing it away, can we recycle, reuse, use these other products for other purposes we never even thought of as possibilities. So very interesting work, and I'm glad we had this chance to visit and get to know a little bit about some of the stuff that you're doing there. I hope the rest of you that joined us here on Renew today have learned a little bit more about the Department of Sustainable Bioproducts and some of the really novel work that they're doing to try to increase the wise use of our natural resources and improve our lives here on this planet. I've been your host, Leslie Berger. Thank you for joining me.